Hello, this is Tom Kirk from Group 8 of Mech 410 at UVic, November 26, 2016. Today I'm going to be showing some basic FEA analysis on a primitive assembly. To start off, we're going to mate our two parts, which is a cone and a solid box. So we're going to go to mates, click the two surfaces we like to mate. We're going to make them coincident. Click yes. Click OK again. So our next step is to go to evaluate interference detection. We need them to be treated, the coincident surfaces to be treated as interference. So that basically treats the two parts as touching. We're going to click calculate. That shows the surface we're looking for. Click yes. So our next step is to go to simulation. We're going to need a new study, and we want it to be in static analysis. All right, our first step is going to be applying a material. Today, we're going to be using alloy steel. All right, our next step is going to be fixtures, fixed geometry. We're going to fix the bottom. We're going to click yes. Next, we are going to be making an external load on the part we inserted, a surface load, force, click the surface you're looking for. Today we're going to be applying 600 newtons. Yes. Next, we need to go to the connections advisor, contact set, automatically find contact sets, select the part, find contact sets, go down. We want no penetration. That means that the two surfaces will not be able to penetrate each other. Go. Yes, we would like to create that. So we have our fixed geometry on our one part. We have our applied load. Now all we need to do is create a mesh density. We'll go a little more on the quality side, find a mesh, press OK. Perfect, and now we are ready to run our force simulation. Alright, so our first graph we have is showing the von Mises stress, obviously the highest at where the applied surface load is. And next we have our displacement, same deal. And our last is our strain, which looks a little distorted, but that's due to our coarse mesh. So now we're going to show how to animate the strain applied. So this is basically the speed of the cycles. Slow that down. Click OK. And oh, I guess that got us out of there. And yeah, that kind of just shows the the cyclic loading. Close that up. And that'll be all for our first part.
For the second part of this video, I'll be showing you how to perform a FEA simulation on a more complex assembly. First off, I'll be showing you how to split the surface on a shaft to only place a force on a certain section of the shaft. So I have a sketch here on the top plane, and I'll be projecting it with the split line feature SOlidworks, which I just clicked, and now I have 4 faces on the shaft, which I can apply forces to each section. Here I'll be just mating it real quickly. Now we've done that, we want to check for the interference, which means that we want to see where each of the parts or components are touching. So we can just select the components which are in the assembly. Just hit calculate. Make sure we check off treat coincidence as interference. And now we just start a new study. Make sure we're just doing a static study for this case. Now we have to apply material to all the parts. For now, we're just going to select an alloy steel for all of them. Simplify. Apply and close. Now we have to check the contact set and set them. So connection advisor, contact set, and we can just go automatically find contact set, highlight the entire assembly, find contact sets. Now we have 4 contact sets because the bearings are made up of 2 solid bodies. And you can just click out of that. Say yes. Now we can apply a fixture. So it's geometry, and we can just apply that to the bottom of the bearings. Okay. After that, you will be applying a load. For this, we will be selecting the top face of the split face, and just apply a 1000 Newton load. Okay. Now we can mesh. The default mesh size should be good for this example. Once we have a mesh together, we can run it. Now, see, we have the FEM analysis of the full assembly, where we can see how the force on the shaft will react with the bearings. And if we want to change the scale to better display it, we can just change that there, and there we go. And that is how you perform a FEA analysis on a more complex assembly in SOLIDWORKS. I hope you found this informative, and thanks for watching.